All right, so now we're doing the second derivative with respect to x. So we're going to take our derivative from before and take the derivative with respect to x. And so I'm going to take this top one and just put them on the top and switch the dx and the dt. And so we end up with this. This way we can now take the derivative with respect to t of what we had from our first derivative. So it's the first derivative and then derivative with respect to t. And then the bottom is just our x prime of t again. So let's try this. Okay, so we have dx dt would be 2t, and dy dt is equal to 2t plus 1. So that means our dy dx would be 2t plus 1 over 2t. Simplifying this would be 1 plus 1 over 2t. So you can see that's all this is. This is our dy dx, right here. And so we're going to take this one again and take the derivative of it and then divide it by this one's derivative. So we end up with d dt of 1 plus 1 over 2t, and then dx dt on the bottom. So I'm going to rewrite this one as 1 plus 1/2 t to the negative 1, so that we can take its derivative a lot easier. And so that's our top. So that would be 0 for the first term, and then negative 1/2 t to the negative 2. And then again, we just take our dx dt and rewrite it at the bottom. So this is negative 1/2 and a half, so that just becomes negative 1/4. Just goes to the bottom. That's a negative 1 coming up here, or those two coming down here. So t cubed. So we end up with negative 1/4 t cubed. So all you're doing is taking the derivative of y and t, putting them together, and then you're taking the derivative of that dy dx again. That's your numerator, and then you just carry down your dx dt down here. Now, so this is our second derivative. So y double prime of x is equal to negative 1 over 4 t cubed. So this is our d squared y dx squared. Okay, so now what we want to know is for what values of t is our function concave up, and when is the function curve concave down? I keep saying function, curve. This is not a function. When is our curve concave up and concave down? And you can kind of see it right here. Right there is our point, and it's concave down here. Right, let's put that in red. And over here, it's concave up. So we should be expecting second derivative here to be negative, and second derivative here to be positive for concave up, concave down. So we just need that one little point. So same thing as before. So that we set equal to 0, so t equals 0. And then we draw a line. We put 0. And so now what we're going to do is plug in some t values to the left and some t values to the right. So t equals negative 1 would be over here, and t equals positive 1 would be over here. So you can even use 100. So if I plug negative in here, it's negative over negative. This is a positive, so we should be concave up. And if I plug in 1, it becomes negative. So this would be concave down. So we are concave up. I've run out of room, so I can put it down here. Concave up when t is between negative infinity and 0. And we are concave down when t is between 0 and infinity. And so now let's double check this with Desmos. Okay, so our second derivative over here, so that's the way our parametric moves. It's coming in this direction. So you can see that that negative value of t here has a second derivative that's positive, and that's part of our concave up. And then when it hits 0, you can see it's undefined. So that's the end of our concave up, and it then becomes concave down. And you can see there's the negative second derivative. All right, let's do it again. Oh, real quick, domain of t here on this one was all real numbers. So we're good. But the domain of t on the next one, well, that's a natural log, which means t must be greater than 0. Whatever we input in there, it can't be 0 or negative. All right, so let's first find our first derivative. So dx dt is equal to 1 minus 1 over t, and dy dt is equal to 1 plus 1 over t. So that means our dy dx is equal to 1 plus 1 over t and 1 minus 1 over t. All right, anytime we have these, we want to multiply top and bottom by t. And so that would end up with t plus 1 over t minus 1. It just makes things a little bit easier. Now our second derivative. So this is going to be the derivative of the top. So we're going to do a d dt of t plus 1 over t minus 1. And then we just write the dx dt on the bottom. So basically we find the derivative and then we do it again, second derivative. So to find the second derivative, you take the first derivative and take its derivative, but then you divide it by dx dt. Okay. So let's take this one's derivative again, because we're going to have to use quotient rule. So derivative of the top would be 1, t minus 1, minus derivative of the bottom would be 1, t plus 1, all over the bottom 1 squared. So we end up with t minus t, which is gone, and then negative 1 minus 1, which is negative 2. So negative 2 over t minus 1 squared. And then dx dt is 1 minus 1 over t. Well, I want it to look the same way as this. So what we're going to do is a little modifying. We're going to make this a t over t, and we're going to put it back together. So this would be t minus 1 over t. You can see why I'm doing this now. So now we have our fractions. So we do a little reciprocal, negative 2 and we end up with negative 2t t minus 1 squared. I mean cubed, because 2 plus 1 is 3. Okay, so now what we want to do is find out for what values of t is the curve concave up and concave down. So you can see I already put a little dot there. This would be concave up, and over here would be concave down. But we don't know what motion it is until we started plugging values in, right? But obviously looking at the graph, I can see that that right there is a broken part. So following the domain, t must be bigger than 0. That would be my first input of t, and we're going to go this direction. So I know that this should be my t values that are less than some number, and these are my t values that are bigger than some number. So let's find out what they are. So we do d squared y dx squared equals negative 2t t minus 1 cubed. And so again, we take the top and set it equal to 0, and the bottom and set it equal to 0. But then you go back to your domain and you look. Well, it says t must be bigger than 0. That's not included. So all we have to deal with is 1. And looking at the graph, we can already see that there's only 1. It's not coming back down. So we put 1 here, and then we pick something to the left, and you can't pick 0 because, well, it can't be 0. So something bigger than 0. So we're going to put a parenthesis here and put 0. Something bigger than 0, but less than 1. So how about 0.5? And we plug it in to our problem. So if I put 0.5 on the top, I would get negative. And I put 0.5 into the bottom, and I also get negative, which is positive. So that means this is concave up. Now something to the right, how about 100? Because it's nice and large. 100 on the top would be negative. 100 minus 1 is positive. So it's negative. So again, concave down. So it matches our graph here. Let's look at Desmos. So you can see there is my first t of 0. Okay, and then it moves, and right here is all concave up. It's very quick to get there because we're only going from 0 to 1. So you can see that the second derivative is positive. And then when my t is equal to 0 and right on past it, our t is equal to 1, You can see there's our undefined value because that was our denominator equals 0. But that's our change in concave from concave up to now concave down. And you can see there's my second derivative is equal to a negative. So we are concave, oops, let's put this in the right color. Concave up from 0 to 1 and concave down from 1 to infinity. There you go. So it's all about the second derivative. So same exact stuff we've done before for finding concavity. You take the second derivative, you set the top equal to 0, bottom equal to 0, and then you plug in numbers to see if it's positive or negative. It's positive, concave up, negative, concave down, because it's still that rate of change.